In our world today, computers are a very important part of our lives. We use computers for smartphones, we use them for controlling appliances, they're in the car, they're everywhere. And my area of interest is not in the computers that exist today, but rather in computers that will exist tomorrow. So the idea is that the computers that we use now are built on very simple logic. So the computers themselves are very complex, but the logic is simple. We represent all information, everything we say, everything we do, by zeros and ones. So when you type a key in the keyboard, it makes a string of zeros and ones. Could be 0, 0, 1, 1, 1, 0, 0, etc. That all the information we have in the world, everything about you, everything about me, history, mathematics, can all be written down as a string of zeros and ones. The computer has two aspects. One is it stores information as zeros and ones, and it changes the zeros and ones to a different string of zeros and ones. And as we know, computers are very powerful, and they can calculate many things, but there still exist some problems that are very hard for computers. If you buy something on the internet and you use a credit card to make a purchase, you type your secret credit card details into your computer and send it over the internet. Why can't somebody steal that information? Why do you think that that information is safe? And the reason that you believe it's safe, probably you believe it's safe because people tell you it's safe. And the reason they tell you it's safe is because they believe that decoding the information, breaking the code, is too hard to do. And if we don't make computers out of zeros and ones and out of what we call Boolean logic, the ways that we manipulate zeros and ones, we can add them together and multiply zeros and ones. And we do the Boolean logic in order to process the information. But if we play a whole different game, then the power of computers can be very different. So the idea that I'm interested in is not to build computers that are made of zeros and ones and made of the Boolean logic to manipulate the zeros and ones, but instead to make use of one of the great revolutions in the last century, known as quantum mechanics. A bit is short for a binary digit, which is just one unit that can take on the values of 0 and 1. In quantum mechanics, we're allowed to have the 0 and the 1, in a sense, coexist simultaneously. A quantum computer with 20 quantum bits would defy any computer that's not quantum to be able to describe its behavior. So the idea is that 20 quantum bits is big. It sounds small by today's standards with non-quantum bits, but 20 quantum bits would be hugely powerful. 2 bits can have the value 00, 01, 10, or 11, which in decimal are the numbers 0, 1, 2, and 3. In a quantum computer with 2 quantum bits, we can have the numbers 0, 1, 2, 3 all existing simultaneously and being processed simultaneously. And then if we take 3 quantum bits, we can have the numbers from 0 to 7. 4 quantum bits, the numbers 0 to 15, and so on. So what makes quantum bits special is that we're able to prepare and process all possible numbers at the same time.